All right, welcome to the video that will explain about the meaning of accumulation points in the real numbers. What is the meaning? Well, first I'm going to tell you the definition. You know probably the definition of accumulation points. Accumulation points in the real numbers, we call the usual topology, right? It's the following. X is an accumulation point if given any open interval a comma b that contains x, there exists a y different from x that is in both. It is in the set a and it is in a comma b. I typically call this the black set. Let me go ahead and call it the black set. Okay, this is the black set. All right, let's just make it black, just to refer that to the black set. So what is the meaning? The meaning is the following. The meaning is the following. X is an accumulation or limit point, accumulation or limit point of A if and only if you can find a bunch of, I call them black points. I'm just going to call them here a bunch of points in A other than X, that get very close to A, that get very close. And I'm going to put in parentheses, they accumulate. They get very close to X. All right, that's the meaning. So we say that X is an accumulation point of A. If you can find a bunch of points in A, I'm going to call them the black points, other than X, such that those points, other than X, so that should, other than X, that they get, let's put it like this, so that they get very close to X, all right? So here's an example. That is the meaning. Why is that the meaning? I can discuss that in another video, but let's move on from this meaning and let's try to explore the accumulation points based on this meaning, all right? That's the purpose of this video. All right, let's go ahead and check it up. So for instance, do you think X equals, do you think, let's go ahead and move this a little bit on the top. And let's put a line right here. And let's put here, X belongs to A, or X that like point, accumulation point. So how to say, let's call it like this. Points, points in that are accumulation and points not in A super A. In other words, these are points of accumulation and points that are not of accumulation, right? So let's take a look. I confirm, not I claim that X equals 2 is an accumulation point. Why is that? Because here is X equals 2, okay? You can find a bunch of black dots here. They get very close to 2. And these black dots are different from X, right? So why is 2 an accumulation point again? Because you can find a bunch of black dots other than 2, here are the points, that they get very, very close to 2. That's why 2 is an accumulation point. Easy peasy. Let's do another one. Let's do, that was 2, that was 2, that was 2. Let's do another one. How about 5, Professor? Yep, 5 is also an accumulation point. Why is that? Here's 5, because you can find a bunch of black dots that get very, very close to 5. You can find, again, a bunch of black dots other than 5 that get very, very close to 5. Where are they? I don't see them. Here are they. Here they are. I'm sorry, here they are. There you go. Right? That's why 5 is an accumulation point or a limit point, right? Here's another one. How about 3, Professor? Yep. Where is 3 in the picture? 3 is here. All right. Can you find a bunch of black dots that get very, very close to 3? Yep. Yep, they get very, very close to 3, and they are different from 3, right? Yep. All right. So how about 4.9? Yeah, 4.9 also makes it. Here's 4.9. 4.9 also is an accumulation point. Why is that? Because you can find a bunch of black dots that get very, very close to 4.9, and they are different from 4.9. In other words, you can find a lot of dots other than 4.9 that get very, very, very close to 4.9. That's why 4.9 is an accumulation point. What about something that is not an accumulation point, Professor? How about this one? 6 is not an accumulation point. Why not? Here is 6. Can you find a bunch of black dots that are very, very close to 6? Yes. Where are they? Here. 6, 6, 6, 6, 6, 6, 6, 6. Because 6 is black, Professor. Look, 6 is black. So I can find a lot of, like 6, 6, 6. They are black points. Yep. Yeah, they are black points. They get very close to 6. Yep, they get very, very close to 6. But they have to be other than 6, silly. Other than 6. And this is not other than 6. Actually, 6 is equal to 6. So you cannot give me those points, silly. They have to be other than 6. Oh, shoot, Professor, I'm sorry. No worries, man. No worries. So 6 is not an accumulation point because you cannot find points that are black that get very, very close to 6. They have to be other than 6. By the same argument, 7 is not a 7 is not an accumulation point. What about 5.2, Professor? I would go with 5.2 is not an accumulation point. Why not, Professor? Here is 5.2. It's a red point. Where is it? Here, 5.2. Why is not an accumulation point, Professor? Because of the following. Well, it's kind of blurry. It's kind of blurry. All right. 5.2 is not an accumulation point because you cannot find a bunch of points other than 5.2 that get very, very close to 5.2. And you may say, yes, Professor, I think I can find them. I would say that you cannot. And you may say, yes, Professor, I can find them. I say, where are they? And then you're going to go like, here, 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 here. Look, Professor, I'm getting very, very close to 5.2. I would say, no, not very close. Actually, you cannot get closer to 5.2. I mean, you cannot get closer than 5, like within a distance of 0.1. You cannot get. The closest that you can get is like at the distance of 0.2, but you cannot get closer than that. You see what I mean? Why not, Professor? Because look, these numbers are less than 5. So you cannot get close enough to 5.2. For instance, you cannot find a point that is within a distance of 0.0001. In that interval, you cannot find a black dot. You see what I mean? Within this interval, you cannot find a black dot. Oh, I see, Professor. Yep, that's why 5.2 is not a limit point. Neither 1.9. Where's 1.9? Is right here. 1.9. You cannot find a bunch of black dots other than 1.9. In this case, 1.9 is not even a black dot, but you cannot find a bunch of black dots that get closer to 1.9. And you may say again, what about this, professor? No, we said that like the closest that you can get with this is like a 0.1, like a distance of 0.1, right? But you cannot get within this interval. You cannot get inside here. You see what I mean? There are no black points in that little interval. That's why 1.9 is not an accumulation point. So you can go like this and say, hey, okay, I know. So 5.9 is not 5.9. 5.9 is not, I don't know. 0 is not. 8 is not. 9 is not. So what are yes and what are no's? Okay, this is yes, 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 check, 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 check. Yes, 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 yes. All these are yes, including 5. No, 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 no. Oh no, oh no. Oh no, 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 like that, right? So this is no, 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 yes, yes. So what is the answer, professor? Here, the answer is the set of accumulation points is just from 2 to 5, including 2, including 5. And you have to exclude 6 and you have to exclude 7 because they are not accumulation points. You see what I mean? So that's the meaning, all right? Thank you very much for watching.